All right, here's where it starts to get complicated. This is probably the most hated topic in all of statistics for all social science students. We're going to kind of breeze through it. I want to make sure that the basic logic is laid out. It's fairly complicated, and it leads, null hypothesis testing is what leads to a lot of misunderstandings in statistics because it's this sort of inverted backwards logic. And the reason it's an inverted backwards logic is because of the way the statistics force us to ask questions. We're going to come back to that, and I'm going to map the two onto each other, but I just need to make sure that everyone's familiar with this. I feel like every statistics class should probably spend a lot of time going over this because people get very confused. Usually in research, we're testing some sort of hypothesis about how groups relate to each other. We'll come back to that. In essence, I'm trying to think of a counterexample. Almost all social science hypotheses, maybe not in econ, at least in psychology, can be brought back to this right here. Are these groups different or are they the same? Now, that's not usually how we ask the question, but that's the mechanics of it, that's what we're actually asking. Okay, so to do this, we got to use null hypothesis statistical testing. The question that it allows us to ask is, say you know some population. You know the IQ of all Americans or whatever, and you want to know, is this particular high school super overachiever or something? But you only get some of the students out, right? What it allows you to ask is, what is the probability that the sample that I just pulled was drawn from this known population? Right? That's all that we can really do with statistics. That's an overstatement. That at a first pass, that's all we can do with statistics. Right? Is ask, what's the probability that this group that I just pulled came from this population? Or alternatively, if you don't know the population, what's the probability that these two samples that I just pulled out came from one single population as opposed to, say, two populations? We're going to come back to this. I can see a couple of you looking around kind of funny. We're going to come back to this. It has to do with how statistics work because all that statistics allow you to do is say, these two groups look like they came from different populations or these two groups look like they came from the same population. Or better stated, we don't have enough evidence to say that these two came from different populations, right? We'll come back to it. So if it's a low probability that they came from the same population, we assume that they came from different populations, right? Or that maybe there's a meaningful difference between the groups. This is what your p-value is, by the way. Your p-value is the probability that the samples you pulled came from the same population, or if you knew a population and you pulled a sample from it, what the probability is that that sample came from your known population.
Can a broad way that you think about it just be that when you're doing this statistics, like you can't assume anything. Like you just have to come in and assume like nothing's there, don't make any assumptions, and like that's the de facto position. And so you get these two samples and you're like, is there any possible way these are from just like the same big population? Just like no, there's no way. Like the probability is so low.
Right. That's
so, like the p-value is so small because like even though I'm trying to find a way to make it so that these are from one population, it's just not happening. They have to be different.
That's a great way of putting it. So rephrasing that with a sort of concrete example, let's say you wanted to know, does Prozac help treat depression, right? The way I'm sure you were all familiar with, the way you would test that is you would get a control group and you'd give them, lemon drops or Red Hots or something, you give them some sort of sugar pill, and then you give the other group Prozac, right? And then you look at these two groups, and of course their means are going to be different. Even if Prozac had zero effect, you know their means are going to be different. But we sort of start out assuming, as Michael was pointing out, that let's just assume there was zero effect. If there's zero effect of Prozac, then they're identical, right? I would have pulled them from the same population, the population of depressed people, right? Does that make sense? So we start off assuming that, and then we run our statistics and say, wow, that assumption seems really improbable. In fact, I would say there's less than a 5% chance that I pulled both of these samples from one population, right? So if that's really, really improbable that they would have come from one population, what's the most likely explanation? That they came from two populations, right? Population of depressed people without Prozac and a population of depressed people with Prozac, right? Another way of interpreting that is that Prozac has some effect on depression. Does that make sense? And that's how this sort of structural logic maps onto the conceptual logic of the actual hypothesis testing that we're doing. Yeah?
I have another question. then if you have like, you have two samples that they have different, whatever, statistical measures, whatever. How do you, like, they could be from the same population, you just chose like from like different like places, or how can you like, because I'm really confused because I'm thinking, okay, I'm referring from the sample to the population, and then it's getting confusing, I think.
Right.
I'm very confused at this point.
Okay. Let's walk through it one more time. We're going to have to keep cruising along. Largely, I knew there was a problem that we might get bogged down in this. And like I said, it's logically sort of tricky. It's like doing mental aerobics logically to understand this, but it's really, really important because this is sort of the structure that our statistics map onto. So let's say you have one hypothetical group of people, right? Let's say depressed people, right? And you want to know something about some way of treating depression, right? One way of framing such an idea is that there's actually two populations that sort of exist hypothetically in the world. One of these populations is depressed people, and one of these populations is depressed people who take Prozac or some other medication, right? Because they're different from each other, which is why they're two populations. If Prozac had zero effect, they would be the same population. Does that make sense? Okay. Problem is, we can't actually measure those populations, right? For one thing, they don't really exist. They're just sort of in our minds. So instead what we do is we pull two groups of depressed people. We give one of them Prozac and we give one of them the placebo. And then we look at it, and when you look at these samples, right, you can see that the samples are different. Those people that took Prozac are actually less depressed than those that didn't in the sample, right? You can measure that. The mean is higher on some happiness index or something like that, right? So you can look at your samples and say, well, the samples are different, right? But we didn't want to know about our samples. We do know about them. We know all that we need to know about them, right? What we really want to know about is the populations or the hypothetical populations that they came from, right? The real question we want to know is, are there two populations in the world? One of depressed people without Prozac and one of depressed people with Prozac, right? Our samples are different, but we need to be able to figure out, are the populations different? The only way you can actually accomplish this using parametric statistics, using these sort of standard statistical measures, is by starting off with the assumption that they're the same. That there are not two populations in the world. There's only one. And this includes both depressed people and depressed people who are taking Prozac, because they're the same, right? So we start off with this assumption. That assumption is your null hypothesis, right? And essentially what you're testing is, what's the probability that my null hypothesis is true? That there is only one population in the world, right? And if you were to pull a sample from, say, the far tail end of this hypothetical distribution, that would be really, really unlikely, right? It seems much more likely then that you probably pulled it from a different distribution, a different population, right? So you start off by saying, let's assume we pulled both our control group and our placebo and our Prozac group from one population. In other words, Prozac has zero effect, right? We assume that. We run statistics on it, and our statistics say the probability of that just happening, that you pulled both of those samples from one population, is really small. Let's say it's 0.05, right? There's only a 5% chance that that could have happened. Well, if it's really unlikely that we pulled them from one population, we're then safe to assume, to some extent, I shouldn't say safe to assume, but we then assume that there must be two populations in the world because it's so unlikely that we would have pulled them from one. Does that make sense? Yeah? And that logic maps onto, if there's two populations in the world, then Prozac must be having some effect. Okay, cool. It's worth rewalking through though, because it's complicated and it also impacts how you actually do all the statistics, what the statistics mean, how you do research design. I mean, this underlays a ton of stuff that we do, and it's kind of tricky, right?
I always thought that we define the population by the measures that we get from the sample.
So,
and then, it's kind of, yeah.
You are in a sense, right? You're defining this population of depressed people with your control group that you gave a placebo to, right? And we're going to come to that with the statistics, that essentially if you didn't know what the population was, you need a control group to estimate what it was.
Right.
Does that make sense? And then you compare your experimental group and say, what's the probability those came from the same group? Does that make sense?
Yes.
Cool. Okay. Any other questions? Cool. I think we'll cruise through this thing because I think that pretty much covered the rest of the hypothesis stuff.